All right, let's get started with our unit test for exploring one variable quantitative data, summary statistics. For the first question, we have each dot plot below represents a different set of data. Order the data sets from the largest standard deviation top to smallest standard deviation bottom. So standard deviation refers to a calculation of the relative distance between data, an average of the relative distance between the data. So the farther apart they are, the more standard deviation they have. So from here we can see that this one has the highest standard deviation. The more this is the one with the more spread, followed by this and followed by this. So this should be our ordering. The following table shows five number summary for the number of gym members at each gym in Shansville. Okay, so we have given data mean, Q1, median, Q3, and max. About what percent of gyms in Shansville have fewer than 56 gym members? Okay, what percent have fewer than 56 gym members? 56 is the Q1, which is 25%. We know that. So fewer than that means the data below it. So it will have 25%. An agility test measures how well a person can change directions quickly and maintain their balance and coordination. A coach had their players test an agility test where 10 is the highest score here, and here are the scores. Find the median scores. So, how many scores do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 scores, and median is the score that is the middle value. So 11 by 2, 11 plus 1 by 2 is 12 by 2, or the sixth data is our median. So first, second, third, fourth, fifth, sixth, which is 9. So our point is median is 9 points. Karina watched a basketball game and recorded how many points each of the 18 players scored. Here are the results. The approximate location of the median is point. Okay, 18 players. So which means 18 plus 1, 19 by 2 is the median, which is 9.5. Now, obviously, we can't have a decimal data. So 9.5 means the average of ninth and 10th data. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the average of that would be here, A. So this is the approximate location of the median. What about the approximation location of the mean, which is the average? Well, is this symmetrical data? Let's see. It is not symmetrical data. Um, so what would be the mean? Let's calculate. We can calculate the mean by, first of all, dividing the entire number with 18, because we have 18 data. So divided by 18. And in the numerator, we would have, let's see, we would have 0 into 2, or this is 1, 2 plus 3. So 2 plus 3. Then we would have 5, 6, 7 once, 8 twice, plus 8 twice. Then we have 9 twice and 10 once. So 9 twice plus 10. Then we have 11, 12, 13 twice, plus 13 twice. Then we have 14, 15, 16, 17. 14, 15. Oops, what's this? 14, 15, 16, 17. 14, 15, 16, 17. Okay, 13 twice. 14, 15, 16, 17. All of that divided by 18. And then we have 35 and 45. So we add plus 35 plus 45. The mean is 12.44, which means it is at location B. So we select B. Jordan asked six people how many apps they each had on their phone. Here are the responses. The mean of the data is 47 apps, which of the following give the standard deviation. So 47 is the mean, so we have to subtract each data from 47, square that, and divide that with n minus 1, because Jordan asks the population, not wait, 8 people how many apps they had each on their phone. So yeah, it is sample, so n minus 1, and 47 8 cannot happen, so it must be B. We take their deviation from the mean, subtract that for each data, and we have to square that, and and the mean is 47, so that is why this is wrong. You have to subtract from 47, and you don't have square in any of these, so I can safely select option B. Each dot in the following dot plot represents the number of goals Lewis scored in one lacrosse session. Okay, find the interval range, IQR of the data in the data plot. So IQR, interval range, is the difference between the Q3 minus Q1. So that is 75% of the data, and this is 25% of the data. How many data do you have? 1, 2, 2, 3, 4, 5, 6, 7, 8, 9. So 9. What is the median? Fifth data. 1, 2, 3, 4, 5. So if this is the median, then we have 1, 2, 3, 4 data left. 1, 2, 3, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, fifth data. So yeah, 1, 2, 3, 4, 4 data on the left, 1, 2, 3, 4, 4 data on the right. So now the Q3 would be median of that again. So 1, 2, 3, 4. So which means the median of the average of 47 and 48. So 47.5 minus the median of 1, 2. Okay, so average is 44. We know that 1, 2, 3, 4. The median is the middle two values. So these two values, which is 44. So 44. This is the interquartile range. 47.5 minus 44. 47.5 minus 44. 33.5. So 3.5 goals. Diego is a wildlife researcher. They were analyzing the mean and median lengths of 9 whales their team had observed. The whales all had different lengths between 23 and 27 meters. Diego found out that they were misreading the shortest length. It was actually 20 and not 23. How will this length dec- how this how will this length decreasing affect the mean and the median? Median will not be affected because you're just replacing a data, and the total number of data remains constant, and so does the median. So the median will stay the same. So the one that says the median will change, we can cross them out. So A and B cross out. Okay, median will stay the same. Median will decrease, median will decrease, median will decrease. Khalas. That's it. We can say C is the answer. Mean will decrease because one data is decreasing from 23 to 20. So C is our option. Okay, the stem and leaf plot shows the number of items in each of the 12 collections in the museum. Two uh, 2 bar 6 represents a collection with 26 items in it. Here's a five number summary for this data according to 1.5 times interquartile rule. For outliers, how many outliers? Low outliers are the data set. So what is the interquartile range? That is Q3 minus Q1. So 13 minus 6 is 7. 1.5 times 7 is 10.5. So which means 6 minus 10.5, because we want to see how many outliers are there from low outliers. So that is, um, since the low one is 6 and the 1.5 times interquartile range, 1.5 times is 7 is 10.5. So which means that if you have a data um, less than negative 4.5, then that is what we consider as a low outlier. Now, do we have one? We don't have. We have, the minimum is 3 lives. So we don't have any then. Okay. A group of Americans participated in a study that involved taking their temperatures during exercise in extreme heat. The participants had a mean body temperature of 104 degree Fahrenheit and a standard deviation of 2 degree Fahrenheit. Doctors analyzing the results prefer to work in degrees, so they counted the data by applying the formula below to each data point. Okay, and if each temperature is converted to degrees Celsius, what will be the mean and standard deviation of the distribution of this new temperature? Okay, so we had a mean of 104. Um, if you multiply this with 5 by 4, so 104 multiplied by 5 by 4, so 5 by 9, sorry, 5 by 9, 5 by 9 times 104, and subtract that from 32, 32. So we just find the mean, we just convert 104 to degree, which is 40. So mean would be 40. So A and B cross out. Now the standard deviation. It doesn't really matter. The standard deviation doesn't change when you multiply anything, because standard deviation is a measure of relative difference, or the relative distance. So if you multiply the entire data set with the same thing, every data moves to the right or to the left. So the relative distance doesn't change, but it do so like sorry, this was the case with negative 32. Yeah, if you um, move it towards the right or the left. Here we subtracted, so we are moving it towards the left, and each of the data is being moved. But if we multiply each data with a number, then the standard deviation does change, because the data gets more spread apart. So what is the standard deviation? If you have a standard deviation of 2 um, 2 Fahrenheit, so if we convert 2 Fahrenheit to degree, what do we get? Let's see. Negative of 5 ninth. Okay, so 2. So we have to perform the square root of that. Wait. Standard deviation, right? And it refers to how far the spread it is from the mean, or um, from each data, the relative distance. So we know that um, degree and Fahrenheit has mm the difference between degree and Fahrenheit is 5 ninth. 5 ninth uh, minus 32. So the standard deviation would not be 2 for sure, because um, you won't get you don't get the same thing when you convert from degree from Fahrenheit to degree. So the answer should be D. Yeah. The answer is D. Okay. So raisins in a scoop of each brand of raisins brand cereal. If the mean of the data set is 7 raisins, find the number of raisins in each scoop of great for you. Okay, so we have 9 number of raisins for good to go, 7 for morning meal. If the mean of the data set is 7 raisins, find the number of raisins in each scoop of grade for you. So we have three types of data interval. So we divide that with three, and we know that the mean is equal to 7, so we can equate that to 7. We take the unknown number of raisins in grade 4u as x, so let that be x, plus we know that we have 9 for this one, 7 for this one, 9 plus 7. So we can find the unknown from here, which is 5. So it must be 5. And that's it. That is the end for our unit test.